Bismillah wassalatu wassalam ala Rasulillah. In this video, we are going to talk about Chapter 17, File Organizations. File organizations has three types of files: unordered files, ordered files, and hashed files. In unordered files or unordered records, records are placed in the file in the order in which they are inserted. So new records are inserted at the end of the file. So whenever we want to add a record or a new record to a file, we go to the last record in the file and we add the new one below the last record. We have three characteristics in unordered files, records in a file. The first is inserting a record. If we want to insert a record, we have to go through three steps. The first is taking the last disk block into a buffer. Second, we add the new record to that block. The third step is rewriting the block back to the disk. So we can consider inserting a record in unordered records in a file as an efficient way. The second characteristic is searching a record. Searching a record is not efficient. Why? Because we are using linear search, and linear search will divide the file into two blocks or two parts. Each part it will be searching for the record in each part separately. So it's an efficient way to search about a record, and we are using B/2 in searching. The third is deleting a record. Deleting a record is inefficient. Why? Because we have two ways. The first is rewriting the block after deleting its content in the buffer. This way is a little bit same as the inserting a record. How? In this way, we have also three steps. The first, we search for a record in a disk block and we put it in the buffer. Second, we delete that record. The third step, we rewrite the block back to the disk. So the difference between inserting a record and deleting a record, that in the first step in inserting a record, that we take the last disk block into a buffer, but in deletion we take the block that has the record that we want to delete. And the second step in inserting, we add the new record, but in the deletion we delete the record. And the third step is the same, we rewrite the block back to the disk. The second method in deletion or deleting record is the deletion marker, and I will give an example that will clarify the meaning or that explain the deletion marker well. So the deletion marker is a bit or extra bit stored with each record. A record is deleted by setting the deletion marker to a certain value that indicate a valid record. So let's do it in this example. As we said that deleting marker is an extra bit. Here are the deleting marker. Okay, if we want, for example, to delete record 1, what will happen? In this case, record 1 is invalid. If we want to remove or delete record 1, the deletion marker will be the value will set to another value. So at the beginning it's R1 is invalid and deletion marker is 0, no value. But when we delete that record, the deletion marker will be any other value. For example, it will be 10. So now 10 for R1 is deleted record. So this is the point of the idea of deleting or deletion marker. So in the deletion, whenever we delete a record, it will reorganize or rewrite the block back to the disk. Okay, now there are 4 factors or conditions. If they exist, we can get with specific results. What are these factors and what are the results? The factors are, first, if we found the file, if the file was an ordered file with fixed length record, with unspanned blocks, and with contiguous allocation, we can first result we can determine in which block the value is located by using the formula I over VFR, which is this formula. The second result is that we can know the record of the block by using this formula I mod VFR. So we have to memorize if those 4 factors happened, we get a result with those 2 results. Now we are going to talk about the ordered records in a file. Okay, as we know, ordered is like 1 by 1 records, or in a specific way that we can say that records are ordered in a specific way. For example, named, we can order it alphabetically or numerically. In this example, it explains the term of ordering field, which is value of field that record ordered based on. Here's an example. We can say that names in each block have been ordered according to the alphabet. Aaron, and then Abbott, and so on. So this is the idea of the ordering field. Okay, files of ordered records. Searching records can be very efficient when we use the binary search. So in ordered records, the first factor or characteristic is searching record using binary search. Here is the algorithm. This algorithm, we use it in binary search. I'm gonna explain how the binary search algorithm work. So here's a file has 4 blocks. Each block has records. So let's assume that we want to search for about a value which is 6, number 6. Now K equal 6. How can we search for this value? L, we assume L at the beginning as 1, and then U, we all know that U is number of file blocks. Okay, let's apply these steps or the algorithm. While U, okay, U, the number of block. How many blocks we have? 4. So while for U greater than L, L now is 1. While U greater than L, do these steps. Begin I which is L plus U, 1 plus 4. The summation is 5. 5 over 2, 2 and half. So we don't consider the half. we consider only the 2. So now it says that we will search for the value 6 in the block number 2. So here it says read book I of the file into the buffer. Okay, we go to this block. It says here if k 6 less than the first record in this block, then u is I minus 1. So let's check. 6 is less than 3? No. So we go to the next step. It says else if k greater than the last record in that block. Okay, let's check. 6 is greater than last number or record? Yes. So we do this step, which is L equal I plus 1. At the beginning, what was the I? I was 2. So we go with the result 2 plus 1, which is 3. So we go back with a value of I 3. So now here it says 3 I. Let's do the in the beginning. Go to the beginning. Okay, u greater than L. Okay, so begin. I is equal L plus u. Now L is L plus u. No, sorry, we go with the value L is equal to 3, not I. Okay, now L is equal 3. 3 plus 4 equals 7. 7 over 2 is equal 3.5. So we don't consider the 5. Now we consider only the number 3. So now we are going to block number 3 and search for the file or the value 6. And then we apply these steps. First, is 6 is less than the first record? No. Is 6 is greater than the last record? Also no. So we go to the third or the last step, which says else if the record with ordering key is equal k in the buffer, either we go with the result got found, or not found. In this case, we found the result, so we go with the we can get a result that we found the value 6 in record, the second record of the block, the third block. Okay. Files of ordered records. We've talked about unordered records and its characteristics or factors, and now we're going to talk about the ordered records and its factors. The first is searching. We've talked about, if you remember, in unordered records, the searching record was what? Was not efficient. But in ordered records, it's efficient because it's already ordered, and we can easily find the value that we are searching for or searching about. But searching on the non-ordering field values is the same as in the unordered file. How could that happen? Let me give you an example. If we have this file, it's ordered, as you can see, it's ordered by the ID. If we are searching by a name, it will be hard. Why? Because the file is already ordered by the ID, and we are searching for the person by its name. It will be hard because the names could be not ordered alphabetically. Okay, but if we search by the ID, it will be easy and efficient way. Okay, the second is deletion. Deletion in unordered was not efficient, but in ordered records it can be done efficiently. We can do it or we can go through 3 steps to delete a record. The first, finding the record. Second, delete and mark the place. Delete that record and mark the place of the record. The third step, reorganize the file periodically. The third factor or characteristic is insertion. The insertion, if you remember, in unordered was what? Was efficient, but in ordered is expensive. It could be happen, but it will be expensive. If does the insertion happen, how could that happen? We can go also through 3 steps. The first, finding the position to insert the record with the value k. Second, make a space for the record with the value k. The third step, put the record with k in the place. So remember, in unordered, searching, not efficient, but efficient in ordered. Deletion, not efficient in unordered, but efficient in ordered. Insertion in unordered is not efficient, or we can say not expensive, but in order it's expensive, but it could happen. As we said, in files of ordered records, the insertion technique is expensive, but it could be done. On the other hand, there are ways that if they have been applied, the insertion will be more efficient. What are these ways? The first is keeping unused space with each record. The second, creating an overflow file. What are these ways? I will explain each of them. The first, keeping unused space with each record for insertion is a good way, but once this is used space used up, the original problem will be resurface. So that means if we use the space or the free space in a file, the initial problem will come back. Let me explain it in another way. For example, let's consider this block with this file with 4 blocks. Each block has a free space, so we can put a record here, a new record. So in this technique, if we use the first way, which is keeping the unused space, let's for example insert a value in each free space of each block. First, for example, let's here put, for example, 10. No, sorry, it has to be considered ordered. Okay, for example, let's put here 2, and here 7, and here 10, and here 40. So in this case, what if we have a new record and we want to insert it in this file? The initial problem is still here. We don't have a free space to insert a new record. So the first way is not working well. So we'll go to the second way, which is creating an overflow file. Okay, so as we said, the first one doesn't work. We go to the second technique or way. In this technique, the actual order or the actual order file is called the main or master file. Okay, so in this way, we will create a new file. Its name is overflow file, and the main or original file, it's called main or master file. So new record will be inserted at the end of the overflow file rather than the correct position in the main file. Okay, In this case, if we want to insert a new record, it will be inserted in the overflow file, not in the original file. Okay, so in this case it will be like this one is the original file, and it will be an overflow file here, which is infinite or infinite number of records. We can insert as much as we want of records. And then when we insert the records in overflow file, when we finish insertion, we go and merge the overflow file with the main file, and it will be ordered automatically. Each record in overflow will go to the correct place in the main file or master file. Okay, modifying field value of a record in ordered records depends on two factors. Okay, here it says search condition to locate the record and the field to be modified either using binary search or linear search. What are the conditions? Search condition involves key ordering key is for the binary search, otherwise it's for the linear search. A non-ordering field can be modified by changing the record and rewriting it in the same physical location on disk. So the modification in non-ordering field is easy, just changing the record and rewriting the record in the same location on disk. And here's in this schedule it says or it shows us the type of organization, the access or search method, the average block to access a specific record. The first is heap or the unordered. How can we access the unordered records? By using the linear search. Okay, the sequential scan, which is the linear search. What about the ordered? There are two types to access the ordered records. The first is sequential scan. The second is the binary search. Okay, the average blocks to access a specific record. If we want to access a specific record in an ordered file, how can we access it? We use this formula, B/2. And the ordered, when we use the order in the ordered file records and we use the sequential scan, we apply this formula. So ordered with sequential scan, B/2. But ordered with binary search, we use the log. So now, if you see the type of organization is heap and ordered, immediately remember that the access or search method is sequential scan, which is the linear scan, and the average blocks to access a specific record is B/2. And the order, if you see the order, it could be sequential scan or binary scan. If it was the sequential, the equation or the way to calculate the average block to access a specific record is B/2, and the binary is log2b. In the next video, we are going to talk about hash files or hash tables. Thank you.